In this issue, summing up the climatic results of 2025, one could have presented a top 5 or top 10 list of the most powerful cataclysms. It would have been desirable for their number to fit into such a list, but reality is harsh. There are thousands of them, and each one stands out with extraordinary force, scale, and record-breaking parameters. Therefore, today we will examine, through the most illustrative examples, how the natural disasters of 2025 differed significantly from everything that had happened before. But first, let us return to the forecasts made by the ALLATRA scientists for the past year.
According to our calculations and mathematical modeling, in 2025, we anticipate a 12 to 15% increase in the intensity of natural phenomena compared to the current year 2024. I purposely emphasize the significance of these figures. They are unprecedented in our modern observational history. Of particular concern is the fact that we are not merely witnessing a linear increase, but rather a progressive, exponential acceleration of this deterioration. Without any collective human action, we have no basis to expect a deceleration or mitigation of this trend. In the coming year, we anticipate the emergence of new climatic and natural phenomena, many of which will differ markedly from those which we have grown accustomed. We will likely confront more frequent instances of extreme weather events, novel combinations of natural catastrophes, and processes that lie beyond previously observed parameters.
Storms. Wellington, recognized as the windiest city in New Zealand and known for its howling storms, faced unprecedented strength in October, even by local standards. From the 21st of October, strong squalls and torrential rains hit the country's capital and parts of the South Island, causing chaos and destruction. In certain areas, winds reached up to 230 kilometers per hour. For several affected regions, the maximum red level alert was declared, a level rarely issued here. In 2025, storm winds reached speeds at which even a brief impact resulted in catastrophic destruction. During the storm on the 17th of December in Wyoming, USA, powerful winds near the state capital overturned more than 100 freight train cars. The disaster left over 500,000 residents without electricity. In the mountains, gusts reached a record 232 kilometers per hour. A November extra-tropical cyclone brought incredibly strong winds to Argentina. For an extended period, instruments at one of the oil fields recorded wind speeds of 312 kilometers per hour, with gusts reaching 352. The suddenness of storms leaves no chance for preparation or seeking shelter from the elements. On the 31st of May, a carnival festival in Germany was abruptly interrupted by a powerful thunderstorm with rain and hail. The sky quickly filled with clouds, the wind intensified, and within just a few minutes the rain flooded the festival grounds. Hailstones up to 3 centimeters in diameter caused injuries to 11 people, mostly in the form of lacerations. Festival organizers reported that in 20 years of operation, they had never encountered such sudden and destructive weather. Radar systems did not detect the hail, and the warning from the German Meteorological Service came at the very last moment. Modern storms are increasingly becoming more dangerous due to the combination of multiple factors: seasonal anomalies, the influence of tropical systems, and increased atmospheric humidity. As a result, phenomena that individually would not be catastrophic together amplify the scale of consequences and drastically reduce response time. For instance, in Mexico, the end of an unusually powerful rainy season coincided with the passage of 2 tropical storms along the country's western coast, which in early October led to record rainfall in at least 5 states and isolated more than 300 settlements from the outside world. In some areas of Veracruz, the water level on city streets exceeded 4 meters. Hundreds of landslides and mud flows destroyed homes, bridges, and roads, claiming the lives of 64 people. On the 2nd of May in India, a fierce and unexpected storm struck the capital region of Delhi, bringing chaos, destruction, and human casualties. The alert about the approaching storm was sent at 2:30 in the morning, at a time when most people were asleep and unable to notice it. The Indian Meteorological Department attributed the storm's strength to an extremely rare combination of factors for the region: the simultaneous influx of moisture from the Arabian Sea and the Bay of Bengal. Last year, there were storms whose development did not fit conventional meteorological scenarios and appeared anomalous, even by modern standards. On the 3rd of December, a powerful cyclone from the Sea of Okhotsk hit Kamchatka in Russia. In the middle of winter, temperatures unexpectedly rose above zero. Snow began to melt rapidly and, mixing with rain, flooded the streets of Petropavlovsk-Kamchatsky. Wind gusts up to 46 meters per second damaged roofs and tore off siding from houses. On the 9th of December, weather anomalies continued with a rare snow thunderstorm for the region. From the 8th of December, Brazil was hit by a powerful extratropical cyclone. Experts noted several anomalies in its development. First, in the capital of the state of São Paulo, prolonged periods of strong wind were recorded, which is unusual for this region, where short, gusty winds are normally dominant. Second, the cyclone's sheer intensity for December, the summer season in the southern hemisphere, was alarmingly high. And third, the most unusual aspect was that the cyclone reached its peak, intensity already over the continent. Pressure in its center dropped to 992 HPa, one of the lowest values in recent decades, whereas normally such systems strengthen over the ocean and weaken over land. In 2025, a clear trend emerged. Storms of the mid-latitudes formed from ex-tropical cyclones increasingly retain their extreme intensity. During the post-tropical stage, these weather systems do not weaken and often become even more powerful, spreading hurricane-force winds and severe destruction far beyond the tropics. A vivid example was the storm that developed as a continuation of Typhoon Halong, which in early October caused heavy rainfall and widespread destruction in Japan. Traversing thousands of kilometers over abnormally warm waters in the northern Pacific Ocean, the storm gained additional energy and, on the night of the 12th of October, struck the western coast of Alaska, USA, with unprecedented power for this region. Winds gusted up to 170 kilometers per hour, and the storm surge exceeded the norm by more than 2 meters. The disaster led to catastrophic consequences. Coastal communities were flooded, and at night many residents found themselves in icy water, clinging to anything to avoid drowning. Houses were ripped from their foundations and carried away by the current, and people had to be evacuated from rooftops by helicopter. One of the most powerful cyclones of recent decades, which hit Europe on the 28th of August, was also a continuation of the powerful Category 5 Hurricane Erin. The cyclone struck Ireland, the United Kingdom, and northern France, bringing winds of up to 160 kilometers per hour, while the coast faced 12-meter waves. A tornado in Italy destroyed a solar power plant with 12,500 panels. In the Baltic countries and Finland, the storm surge raised the Baltic sea level by 1 to 1.5 meters above normal. In parts of the Balkans and Hungary, temperatures rose 8 to 10 degrees Celsius above normal, setting a late summer record. It is noteworthy that the cyclone's impact spread across almost the entire continent of Europe. This is a trend gaining momentum. Storms are beginning to spread across almost entire continents.
Mamma, guarda che sta arrivando una cosa.
One such weather monster was the winter storm that struck North America on the 29th of November, as Americans were returning from Thanksgiving celebrations. The storm system stretched from the Gulf of Mexico to Canada. More than 25 million people were warned of the approaching severe weather. In the Midwest, record snowfall blocked roads and disrupted air travel across the country. One of the most dangerous features of modern storms is precipitation. It falls in such volumes that neither the soil nor urban drainage systems can absorb it in time. Forecasts often fail to reflect the exact location or actual intensity of such downpours. The result is that water accumulates rapidly. Floods occur almost instantaneously, without a gradual rise in river levels, leaving no time for warnings and making people defenseless against the sudden impact of the elements. Abnormal precipitation. One of the deadliest natural disasters in the history of Texas, USA, occurred on the night of the 4th of July. Central areas were hit by intense rainfall. In some locations, more than a month's worth of precipitation fell in just one day, up to 250 millimeters, of which 100 millimeters fell in just 1 hour. Rivers overflowed rapidly, flooding settlements in just a few minutes. The most tragic events took place at the Mystic Girls summer camp, located on the riverbank. Water arrived suddenly while the children were asleep, and many were trapped. Communication with the camp was completely lost, and washed-out roads blocked access for rescue services. According to official information, 27 children and staff members died there. Overall, the disaster claimed the lives of 137 people across the state. Local authorities admitted that they had not anticipated a disaster of such magnitude, and preventive evacuation of residents was not conducted. In mid-December, Middle Eastern countries were hit by powerful and rare winter storms. In Iran, on Kish Island, more than 140 millimeters of precipitation fell in less than a day, exceeding the annual norm. In Isfahan province, snow fell for the first time in 20 years. In the mountainous areas of Khorasan Razavi, the snow cover reached 50 centimeters. The disaster had extremely severe consequences for agriculture. In several agricultural provinces, from 60 to 100% of tomato plantations, covering about 1,000 hectares, were destroyed. In the United Arab Emirates, the storm brought thunderstorms and hail. In the Emirate of Ras Al Khaimah, precipitation over 2 days exceeded the annual norm. At the end of July, Beijing, the capital of China, received in just a few days almost as much precipitation as it normally gets in an entire year. The disaster claimed 44 lives. The largest number of fatalities occurred at a nursing home, where water rose more than 2 meters, leaving many elderly residents with limited mobility unable to be rescued. Authorities acknowledged that existing rescue plans were ineffective, and the city's flood protection system has serious gaps. The events in Beijing demonstrated that standard response schemes no longer work, even in countries with well-organized and technically equipped emergency services, such as China. Today, precipitation can reach such incredible scales that even residents of countries accustomed to seasonal flooding are unprepared for the force of events that surpass anything they have experienced before. In October, central Vietnam experienced a catastrophic flood following record rainfall. More than 1,700 millimeters of precipitation fell in just one day, making it the second highest daily rainfall ever recorded in the world. The consequences of the flood were catastrophic. More than 65,000 households were submerged, agricultural lands were destroyed, and several thousand livestock perished. November rains in Daklak province broke all historical records, reaching up to 1,800 millimeters in some areas over a single week. The flood began very rapidly. Water swiftly inundated homes, and people had to break through roofs to escape the powerful currents. Many families were trapped for about 30 hours. Social media were flooded with calls for help. Unfortunately, the massive flood claimed 98 lives in the country. In December, the country once again faced destructive rainfall. In Kan Hoa province, hundreds of families fleeing the flood were forced for the fourth time in a month to leave their homes. Many still believe that catastrophic floods are primarily characteristic of the humid tropics. However, it is enough to look at what is already happening in temperate countries. Who could have imagined that people in these regions would start dying from ordinary rain? On the 30th of September in Odessa, Ukraine, almost 2 monthly rainfall norms fell in just 7 hours. Streets, underground passages, and parking areas were flooded. People waded through water up to their waists, strong currents knocked them off their feet, and many suffered hypothermia due to prolonged exposure to the cold water. The disaster claimed 10 lives. Among them was a family of 5 with a child living in a basement. In just 15 minutes, the water rose approximately 4 meters, leaving them no chance of escape. Elba Island in Italy also came under climatic pressure. On the 19th of December, residents of the island were hit for the 4th time that year by a powerful storm, describing it as a recurring nightmare. Extreme rains triggered floods and landslides, cutting off some villages from the outside world. It is obvious that the consequences of such an untamed force are colossal. Hundreds of thousands of square kilometers of flooded territory, millions of dead animals, destroyed infrastructure. All of this can be restored, but human lives lost to catastrophes are gone forever. In Queensland, Australia, at the end of March, prolonged torrential rains caused a historic flood. In the town of Eromanga, the volume of rainfall almost reached 2 annual norms. An area of approximately 500,000 square kilometers, including arid regions with the largest livestock farms, was submerged. More than 100,000 head of livestock were swept away by the current. In southern Thailand, a so-called rain bomb struck in November. The forecast of such an event was made only 2 hours before the water flooded residential areas, and it all happened in the middle of the night, leaving minimal time for preparation and evacuation. In Hat Yai, many residents spent several days on the roofs of their homes, deprived of water and food. Large snakes floated in the flooded streets. The 2 lower floors of the main city hospital were flooded. 600 patients were at risk, including 50 in intensive care and 30 infants in the newborn ward. The fury of the storm claimed 33 lives. Most of the victims drowned or suffered fatal electric shocks. In Nigeria, the last days of May brought one of the deadliest floods in the past 60 years to the city of Mokwa. According to eyewitnesses, the water arrived suddenly and rapidly from afar, catching sleeping residents off guard. A powerful current over 2 meters high began sweeping everything in its path. The death toll exceeded 1,000, many of whom were carried by the raging flow into the Niger River, according to rescuers. Against the backdrop of the overall increase in atmospheric moisture, precipitation is becoming increasingly unevenly distributed. Air currents carry moisture over long distances, leaving entire regions without rainfall, and even the precipitation that does fall often only worsens the situation. Prolonged droughts dry out the soil. During intense rains, water cannot be absorbed and flows over the surface into rivers and seas, failing to replenish groundwater. As a result, the risk of flooding increases. Drought. In Kanine, a city on the east coast of South Korea, the most severe drought in the entire observation period was recorded. At the beginning of September, the water level in the Obong Reservoir, which supplies about 87% of the city's needs, fell to 11.5% of its total capacity, effectively reaching the bottom. For the first time in the country's history, a state of emergency was declared in the city due to drought rather than fire or flooding. Authorities imposed strict restrictions on water use. Supply to residential homes was allowed only 2 hours per day, 1 hour in the morning and 1 hour in the evening. Despite heavy rainfall on the 12th of September, when more than 100 millimeters fell, the reservoir level rose only to 16%, enough for roughly 10 days of supply. In the summer and autumn of 2025, countries in the Tigris and Euphrates basin experienced catastrophic drought. Due to heat and precipitation deficits, rivers dried up, and Iraq and Syria faced the threat of hydroelectric plant shutdowns and crop failures. Iran experienced one of the most severe water crises in its history. From October to November, the country received only 19% of the normal rainfall. By November, 19 reservoirs in the country were filled to less than 5%, and key water bodies, including Karaj, dried up so much that their beds could be freely crossed on foot. Hail. Around the world, hail is becoming a serious threat. Its quantity and size, once thought impossible, are shocking. Hail destroys cars and roofs, devastates crops, and injures people. This is no longer isolated incidents, but a new, deadly climatic trend. One of the most alarming signs has been the loss of seasonality. In the middle of winter in Australia, heavy hail fell, covering the desert with ice, and temperatures dropped to 0 degrees Celsius, extremely low for the region. It was completely unprecedented for hailstones up to 2 centimeters in diameter to fall in Lipetsk Oblast, Russia, at the end of November. A period when temperatures there usually hover around 0 degrees. Another feature is the unusual accumulation of ice. In mid-August, Mexico was hit by a short but extremely intense hailstorm, paralyzing the city of Tlaquepaque in just 15 minutes. Roads turned into frozen, impassable rivers, and dozens of drivers were trapped with no way to move. In October, the Bolivian city of Tarija was struck by a heavy rainstorm with hail. In just a few minutes, streets were covered with ice, in some places almost 2 meters thick. The weight of accumulated hail caused the collapse of roofs at hospitals, schools, and kindergartens. Hailstones with a diameter of 10 centimeters or more are officially classified as giant, and such cases are no longer rare. These blocks can penetrate roofs, smash cars, and injure people. In early September, the U.S. state of Kansas recorded hailstones over 10 centimeters in diameter. July in Latvia saw record hail. Hailstones reached 11.5 centimeters, the largest size ever recorded. This was the first officially recorded giant hail in Latvia and was entered into the European Severe Weather Database, ESWD. Look at the chart showing the number of large hail events in Europe. It demonstrates exponential growth. The scale of damage caused by hail is also increasing rapidly. On the 8th of May, Xi'an, Shanxi Province, China, was hit by a sudden hailstorm with hailstones the size of chicken eggs. According to a car dealer, none of the more than 300 cars for sale survived. Bodies were dented and windows were shattered. A hailstorm in Canada in August caused destruction across an area approximately 15 kilometers wide and almost 200 kilometers long. The consequences for crops were catastrophic. Grains were destroyed, corn lost all its leaves, and meadows and pastures were left bare with uprooted grass and broken shrubs. Livestock perished on farms, and farm buildings and residential homes were damaged. In the Brazilian municipality of Erechim, hail lasted about 20 minutes, causing enormous damage. More than 5,000 buildings were affected, windows and car bodies were broken. At least 268 people were injured by hail impacts, glass shards, and collapsing roofs. A state of emergency was declared in the city. Why are we facing such severe natural anomalies? The obvious explanation is the rise in global temperatures and the increase in atmospheric moisture. But this is only one of the reasons. Artificial material has begun to interfere with climatic processes, and when creating it, we humans never imagined that over time it would become our invisible killer. We are talking about micro and nanoplastic.
The primary danger of micro and nanoplastics lies in their unique ability to accumulate electrostatic charge on their surface. The Alatra scientific group warned about this phenomenon 20 years ago. How do plastic particles acquire this charge? It occurs through manufacturing processes, friction and contact with other surfaces, changes in surrounding environment, such as pH, ionic composition, and humidity. Depending on their chemical structure, plastic particles can acquire either a positive or negative charge. The surfaces of these particles may undergo ionization, imparting a stable electrostatic activity to them. This means that nanoplastic particles are not merely inert polymers. They are charged bodies actively interacting with their environment. In the atmosphere, charged nanoplastics act as a condensation nucleus, accelerating cloud formation and causing droplets to freeze at temperatures 4 to 10 Celsius higher than usual. This leads to abnormally large hail, anomalous precipitation, and disruption of the hydrological cycle.
And because the atmosphere now contains trillions of charged micro and nanoparticles of plastic, its electrical energy increases. As a result, the frequency and abnormality of lightning discharges are rapidly growing. Thunderstorm activity. Over the past 5 years in India, the number of lightning strikes has increased almost fourfold. Fatalities from lightning, always a serious problem in India, have now reached catastrophic levels. From April to July 2025, 1,621 people died. In 2025, lightning activity in the USA was 20% higher than the previous year, reaching a maximum for the past 8 years. Over less than a week in autumn, about 8 million lightning strikes were recorded over Australia, more than 4 million of which occurred in Queensland. In the Arctic, thunderstorm activity has increased particularly sharply. Atmospheric physicists note that historically, lightning in this region was almost never recorded. However, over 12 years, starting from 2010, the number of strikes increased 70-fold, from approximately 100 to over 7,000 per year. For the cold and dry Arctic climate, this is an unprecedented increase. If scientists register these changes in the Arctic with instruments in other parts of the planet, anomalous thunderstorms are already a visible reality for many people. At the end of November, residents of the European part of Russia witnessed particularly powerful and frequent lightning discharges. The current of individual lightning strikes reached 486 kiloamperes, while the average amplitude of a lightning discharge is about 30 kiloamperes, 16 times lower. The electromagnetic pulse was so intense that instruments detected its signal at a distance of 700 kilometers from the strike, whereas usually at such distances, the signal is weak or absent. In the temperate latitudes, such levels of thunderstorm activity would be considered abnormally high even in summer, and for late autumn, this is truly unprecedented. With the increase in the atmosphere's electrical energy, dry lightning strikes have become more frequent, significantly increasing the risk of fires. In September 2025, Central California, USA, was hit by dry thunderstorms. Approximately 11,000 lightning strikes were recorded in just 31 hours, causing numerous fires. Rare and little-studied atmospheric phenomena, such as sprites, have also been observed more frequently. These huge glowing red structures form above thunderclouds and rise to heights of 40 to 80 kilometers. Summing up this part of the review for 2025, we want to discuss the value of time. The topic may seem unexpected, but it is closely connected to what you have already seen in this episode. For many years, scientists and volunteers from Alatra warned that global crises were becoming irreversible and that disasters would intensify and affect all regions. They explained, demonstrated, and reported. Yet the response of the global community was minimal. Today, the consequences of the climate crisis are visible to everyone. Now it is an axiom that requires no proof. And here we again turn to the topic of the value of time. If back then we had begun actively seeking and developing solutions to the climate problem, which will not disappear on its own but only intensify, today we would not be witnessing disasters of such scale, such a sharp increase in the force and abnormality of natural phenomena, and most importantly, such numerous casualties. Millions of people have already suffered, and even more will suffer. Hundreds of thousands have already died, and at least some of these lives could have been saved. But the time has been irretrievably lost. Nevertheless, there remains faith in humanity and in each individual, that we are capable of learning from our own mistakes, that we do not want to repeat the fate of those already struck by disaster, and that we will not allow the loss of our loved ones. Understanding the value of time compels us to speak openly and directly. As humanity, we have already lost many opportunities to mitigate the consequences of climate catastrophes, reduce the number of those affected and deceased, and gain time to search for a global solution. In the second part of the final episode, we will further discuss missed and remaining opportunities. But now it is important to focus on yet another planetary threat. In terms of its consequences for humanity, this threat is no less serious than the climate crisis. We have already mentioned it, micro and nanoplastic. We have created a monster that not only surrounds us, but is already inside us. The popular science film, Nanoplastic, A Threat to Life, presents cutting-edge scientific data and expert opinions on how micro and nanoplastic destroys ecosystems, affects humans, and why understanding this threat is critically important for the planet's future. Scientists have found that the highest concentrations of nanoplastic are concentrated in human brain tissue. This triggers a continuous process of destruction inside the brain, as a result of which a person loses the ability to adequately perceive reality and even obvious threats. They stop logically connecting facts, making reasonable decisions, and lose control over their own life. This means the end of human thinking, and with it, our collective end. Because it is precisely now that we especially need a clear, sharp mind and the ability to think soberly in order to find a way out of the climate crisis and preserve our tomorrow. Time is the most precious resource, and for every day of inaction, we all pay not only with our sanity, but with the irretrievably lost lives of people.
The end of 2025 and the beginning of 2026 were marked by increased seismic activity. Over just 3 weeks, there were 95 seismic events with magnitudes of 5 and above, 9 of which were extremely strong, with magnitudes of 6 and above. Here are just a few of them. On January 6, 2026, at around 10:18 in the morning local time, an earthquake with a magnitude of 6.2 occurred in the eastern part of Shirmane Prefecture, Japan, with a focal depth of approximately 6 miles. The maximum seismic intensity of 5+ was recorded in the cities of Matsue and Yasuji, Shirmane Prefecture, and in Sakai Minato, as well as the towns of Hino and Kafu, Tottori Prefecture, with shaking felt over a wide area from northern Kyushu to the Kinki region.
島根県安来市の民家の庭なんですが、石灯籠が倒れています。
User reports indicate falling objects and halted elevators, especially near the epicenter, while there was no threat of a tsunami. An earthquake with an intensity of 5+ or higher, whose epicenter is located in the eastern part of Shermaine Prefecture, has been recorded for the first time since 1919, that is, since systematic observations began by the Japan Meteorological Agency.
Tranquila, silencio. Temblor. Temblor, temblor.
On January 9th, at 4:36 in the afternoon local time, Peru experienced an earthquake with a magnitude of 5.3 in the Ica region, with the epicenter 27 kilometers, approximately 17 miles, south of Palpa. The focal depth was 30 miles. The tremors were mostly felt in the southern districts of Lima, Chorrillos, Villa El Salvador, and Villa Maria del Triunfo, as well as in the Nazca province.
Puto sos pen.
Two weeks earlier, the country experienced a stronger earthquake. On December 27, 2025, at 9:51 in the evening Eastern Time, an earthquake with a magnitude of 6.2 occurred. The epicenter was 22 miles east of Puerto Santa, and the seismic focus was at a depth of 41 miles. It resulted in 25 injuries, 12 of which required hospitalization, and caused material damage, including damage to the main hospital, schools, and residential buildings. Later that same day, at 11:05 in the evening local time, a strong earthquake with a magnitude of 7.0 struck off the northeast coast of Taiwan. The epicenter was located in the sea approximately 21 miles east of Ilan County, near the city of Tuching, with a focal depth of about 45 miles. The shaking was felt across nearly the entire island for a duration of 10 to 21 seconds. A national earthquake warning was issued 15.2 seconds after the quake began. The delay was attributed to the great focal depth and the offshore location of the epicenter. No reports of casualties or injuries were received. In some areas, there were gas and water leaks, cracks in pedestrian crossings, and localized structural damage. Goods fell off shelves in stores. Taiwan Railways temporarily suspended service on the Jiaoxi, Shuaoxian section. 6 high-speed rail trains were delayed, and the Taipei Metro operated at reduced speed for about 20 minutes.
Please use the intercom to request assistance.
Unfortunately, what Alatra scientists have been warning about for many years is unfolding before our eyes. The global community has not yet responded with sufficient responsibility and action to forecasts of the exponential increase in earthquakes worldwide. Apparently, this is because neither the scientific community nor the governments of countries currently have effective measures to counter such a planetary threat. Therefore, it is crucial that everyone becomes aware that even at this stage there are solutions that can be applied in the fight against the climate crisis. We encourage you to familiarize yourself with them and share this information with everyone around you.